Modern math comprises of four sections: counting, arrangement, probability, sets, permutation, and combination. However, these areas come under the chapter of arithmetic. So there's no separate section called modern math. It's part of arithmetic per se. Today we'll understand how to solve any modern math question which comes in your exam. In your exam, you would get around 10 questions in this section. These are all higher weightage questions. First, let's start with counting. I have started off by asking you these two simple questions. First one, how many dots are there? Can you count the number of dots which are there on the screen right now? You might have counted like 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there any other way? Yes, you can count the 3 rows and you can count the 3 columns, and then you can say 3 into 3 rows into columns. So you have totally 9 dots here. Let's see the next question. How many routes are there from A to C? Let's say A and B are two cities, and I'm drawing the roads from A to B. You can see there are 3 roads connecting A and B. Now let me take it forward, and let's say C is another city, and these are the roads connecting B and C. How many roads are there? So generally you could count and say A to B the top, and then B to C there are 2 roads. Or you could say A to B is in the middle road, and there are again 2 roads from B to C. Or you can say A to B there's the third road, and there are 2 more roads from B to C. So totally you got 6. There's one way of counting. You can see A to B has 3 roads, B to C has 2 roads, and if you multiply 3 and 2, you will get 6 again. So from both these examples, you see that multiplication is the rule of counting. Whenever you want to count any item, always use multiplication, not addition, subtraction, or division. Okay, now let's take another sum. The basic rule of counting is multiplication, and here is an illustration. In how many ways can 5 students get into a train with 5 compartments? Take a minute, pause this video, and try to solve this. Okay, let's start counting. The step 1. Whenever you see sums like this, always focus on the picking of the objects. The other alternative is placing them. Now you must always focus on the picking of the objects, because that's how you do these sums. So here there are 5 students. You will have to pick the student and put it in the compartment. Similarly, pick up, let's say, a ball and put it in the basket. Don't focus on the basket, focus on the ball, picking of the object. Okay, so here there are 5 students. Pick up 1 student at a time. That's the rule. So here we have 5 students. I would suggest that you put 5 dashes. So let's say you pick up 1 student. The first student, in how many ways you can place this first student? You can put them in any of these 5 compartments, right? So there are 5 ways of filling the first student. The second person, you can put them in the same compartment, so that's another 5 ways. The third person, 5 ways. Fourth person, 5 ways. So the answer for this question is 5 into 5 into 5. We are doing multiplication because there's a fundamental rule of counting. Okay, now you take some time and compute the sum. Okay, so here there are 5 people, so put 5 dashes. Now the first person you can fill in 5 ways. The second person you can fill only in 4 ways, because you can't put the same first person, the second person in the same compartment as the first guy. The third person can be filled in 3 ways. The next person can be filled in 2 ways. So you would get 5 into 4 into 3 into 2 into 1, and that gives you an answer of 120. Okay, now you try out this sum. How many ways can 5 students get into a train with 5 compartments? The condition is no one should get into compartment 2. So as usual, you put 5 dashes. Pick up the first guy. He can't get into compartment 2. So how many ways can he get into? Yes, he should get into any of the other 4 compartments. So the first person is 4 ways. Can the second person get into the same compartment? Yes. So it'll be 4, 4, 4, 4. And then as usual we multiply, and then you get the answer. I hope it's clear. Now you try out this. Okay, now pause the video and try out this sum. So 5 students, 5 compartments, A and B should be in the same compartment. So 5 dashes. Now the first guy can go in 5 ways. B, he has to go into the same compartment where A is, so he can go only one way. So that's 1. Now here there are the two conditions. One is, let's say there's nobody else gets into any other compartment. So if that's the case, then the third guy gets into any of the 4 ways. The next guy gets into 3 ways, the next guy gets into 2 ways. Or if everyone can be in the same compartment, then it would be 5 into 1 into 5 into 5 into 5. So there are two conditions out here. Now you try out the sum. Pause the video for 1 minute and try it out. So as usual, there are 5 dashes. A and B should not be in the same compartment. So the first guy can go in 5 ways. The second guy can't go into the same compartment as A, so it should be in 4 ways. C, D, E can go in any of the other compartments. So that'll be 5, 5, 5. Okay. So these are the overall rules. Try out the sum. In how many ways can 5 students A, B, C, D, E get into a train with 5 compartments? C, D, E should be in the same compartment. A and B should be in the adjacent compartments. Do it yourself. Okay, C and D and E should be in the same compartment. So A can go 5 ways, B can go 5 ways, C, D, E, C can go 5 ways. D and E should be in the same compartment as C, so that can be one way. Is this clear? As usual, multiply. A and B should be in adjacent compartments. Now here there are multiple possibilities. I hope you got all of them. So A is 5 ways. B can't be in the adjacent compartment, right? But can he be to the right of A? Can he be to the left of A? There are two. If A is in the corner, then there's only one possibility. But if A is in the middle, there are two possibilities here. Can you observe the different possibilities? So you'll have to take each possibility and then you'll have to arrive at an answer. So let us try out the first case. A is in the corner. So if A is in the corner, B cannot be in the next place. So B can go in any of the remaining 3 ways. C can go in the 4 ways, 5 ways. D can go in the 5 ways. E can go in the 5 ways. So the total number of cases here is 3 into 5 into 5 into 5. The next possibility is A in the second compartment. Now here B can go in how many ways? He can go in 2 ways. Everyone else can go in 5 ways. Yes, did you get that? Okay, let's put A in the third place. Now B can go in how many ways? B can still go in 2 ways. Everybody else 5 ways. And now let's put A in the fourth place. That's again the same, 2 into 5 into 5. And the last case would be A in the fifth compartment. It will be the same figure as that what you get in the first compartment. So you will have to manually shift A and then you'll have to count the number of ways of doing the other cases. So you'll have to find those individual numbers and then what would you do to all these numbers? Here you must see one case, like all these 5 cases won't happen parallelly. Just one of these cases will happen at a time. So it's either the first case or the second case or the third case or the fourth case or the fifth case. It's not all the 5 cases happening at the same time. Whenever you have a condition like either or, either the first one or the second one, then you will have to add up all those numbers. So here we have either first case or the second case or the third case or the fourth case or the fifth case. The rule is addition. So either or, add. If it is and, like here we have to arrange the first guy and the second guy and the third guy and the fourth guy and the fifth guy, then you have to multiply all the numbers. That's why we're multiplying 3 into 5 into 5 into 5 into 5. So either or is addition and is multiplication. So in this case we'll have to get those individual numbers, like 3 into 125 is plus 2 into 125 plus 2 into 125 and then add up all these numbers.